My name is Ishmael Rivas, instructor here at Shasta College. Today I'll be doing a demonstration on a pressure compensated hydraulic pump. Hydraulics is in many of the machines that you'll see around you. Almost any machine you see, whether it's in a field, whether it's on a construction site, road building, they're going to have hydraulics on those machines. Here at Shasta College, we have added more and more hydraulics training so that our students can get more experience and go out into the workforce and find high-paying jobs. This pump is special on these machines because it is pressure compensated. Pressure compensated means that this pump will automatically adjust its pressure based on what the system needs and what the load is requiring. So this pump is actually on probably about 90% of the machines out there. So on this pump right here, when you are setting up to do a pressure compensated test or adjustment, first thing you want to do is make sure that you have this valve over here open. This right here is a ball valve, and it needs to be open, allowing your pump to have adequate flow at all times. When you turn on the pump and that's open, pressure will leave the pump coming out of this hose and coming through this flow meter right here. So right here, this is called a flow meter. This is a diagnostic tool. Its job is to tell me as a technician how much flow that pump is producing. Without this flow meter right here, I really have no idea how much flow is coming out of that pump. So what you're going to do is you're going to turn on the pump. When the pump turns on, you'll have pressure coming out through this line. Right here, I have a pressure gauge here on the side. This pressure gauge is just as important as this flow meter. So pressure gauge, if you think about it, it's in the name. It's a gauge that reads pressure. A flow meter is a meter that reads flow. So when the pump turns on, flow goes through this flow meter and it's going to come out through a filter. Now, after you turn on the system, right over here we have our adjustment, this little rusty piece right here. This is our pressure compensator. This is in control of this pump. Inside of this pressure compensator, we have heavy springs. There's also a little small spring in there too. We have heavy springs, and as I adjust this in, this one I can adjust by hand because it's a demo unit. On a real machine, I would need 2 wrenches because we wouldn't want it to be that easy to adjust. But for demonstration purposes, this one is hand tight. Anytime you're setting one of these pumps and we're adjusting this, if the pump is running, you never want to be backing out this adjustment while the pump is running. A big issue if you're backing out that adjustment is you are slowly decreasing the amount of threads that are going into the pressure compensator. On this side of the pump, you could have thousands of PSI, and you don't want to find out that you're on your last thread by this thing squirting off over there, and usually it just makes a huge mess. But if you were in front of it when it came all the way out, it could definitely hurt you. You could have issues like fluid injection, so there's some danger. So far, we haven't hurt any students. So we would start up the pump. After the pump is running, we'd start turning this in, and we should see a change on our pressure gauge as we bring this adjustment in. If we're not seeing a change, we have some other issues, and we'll need to look a little deeper. We want to shut off the system and make sure we got adequate flow, and we have adequate supply right here to our pump. If everything checks out okay and you have adequate flow, adequate supply, everything's working fine, you could go ahead and make your pressure adjustment. After you make your pressure adjustment and you've turned everything all the way to the exact number, so for instance, if I wanted to set this at 2,000 PSI, I would adjust this while looking directly at the gauge. I need to make sure that as I adjust it, it comes right to 2,000. If I'm being kind of sloppy and I just start moving this really quickly, I could pass 2,000 and it could go up to 2,005 PSI. Now that may not seem like a big difference, but if I get to 2,005 on my adjustment, you know, human nature, you'd kind of think, well, why don't I just back it off just a hair? Truthfully, it wouldn't break if I backed it off a hair because I just came in, but what's wrong is the spring inside of there is a mechanical spring. You don't want to set a mechanical spring when you're backing it off. You want to set it as you're coming in while it's under tension. If you set this while backing off or coming down to a pressure, you're going to have a very inaccurate setting. As the machine runs, that could change and your setting is going to be lower than it should. Make sure that when you're adjusting it, you bring it into pressure. If you pass it, you got to shut the machine off, back it way off beyond, so all the way down to probably 1,000 PSI, and then come back up to that pressure setting. So when you come into class, you would have to set this up yourself. Because there's some danger here, again, no one's ever getting hurt so far. It's been 15 years, no one's ever hurt, but nobody's ever hurt because we follow all the safety protocols. So I appreciate it. Hopefully you get to set up a pump one day and you can see the effect of your adjustment. So again, my name is Ishmael Rivas, one of the instructors out here at Shasta College. If you're interested, please reach out to a Shasta College counselor. They'll be able to give you the information you need to help set up your beginning into the diesel technology program.